Here we go. You should have something like this when you launch our studio for the first time. I need, I'm sorry, I will be bothering you very often because I need very frequent feedback from you. It is really very easy to get lost because if you are in live lessons, I can see you and I can see whether some of you stays behind. But I cannot know what is your situation at the moment because I don't see you. So I need some feedback because I do not want to lose any of you. We need to be able to go ahead all together. This is possible, I know, because I've been teaching art for 10 years now, and it is really possible that we go ahead together, but we need to stay together. So I need frequent feedback from you. Please give me a feedback on the fact that your console looks like mine. You must have 3 windows, maybe 4, if you have already opened a script. But what you should see, is something similar to mine. So, good. We have 3 windows, but I need to open a new one now by using the menu, File, New File. We open another script. And then I'll tell you what the script is. By the way, I put some slides on Unistudium, and this is the first thing we need to do. Case sensitivity. R is case sensitive, and this is not common for us, especially if we work with Windows, where Windows is not case sensitive. In R, we have such case sensitivity, which means that writing A in capital letter is not the same as writing, an A in small letters. So what happens with R is that we make a lot of these stupid mistakes, such as making a mistake with the caps, or in general, to not writing precisely names of variables. And I can tell you that it may take hours before we find a small spelling mistake inside our code, if the code is very long. So we need to give ourselves some discipline when writing names. So we need to write names according to some personal rule. For example, I use names where the first letter is always capital. The names are parted by using dots or by using a different cap. I will show you some of these rules, but nonetheless, I still make mistakes, spelling mistakes, and these are always responsible for losing a lot of time and maybe some headaches now and then. So this is very important. Another thing, spaces. Spaces in code are allowed, but not in certain positions, I will tell you. So be very careful about how you write things. Small caps, big caps, capital letters, small letters, spaces or not spaces. Otherwise, really, we lose a lot of times. So there are some suggestions for installation here, and then, but you didn't have problems with that. Now, I already told you that we have 4 panels or panes. They are called panes within the R Studio. And we write the code in the script or source pane, and we send the code to the console pane by using these commands here. So Control R or Control Return. If you have Mac, you will use Command Return, right? And be careful, as I said before, but I need to repeat this, the code in source pane is not executed unless you send it to the console. I always make this comparison. It's like writing a WhatsApp message. Our mate cannot see the message until we send it to him. So it's not enough to write the message in our smartphone. We have to send the message. And R is like this. We need to write the code in the source pane and then send it to the console, right? So let's start. Another suggestion here. This is not fundamental, but we can write comments in code. I will show you how to do that. So first thing to know, in R, we work with assignments. I go back to the console. So if I write something like, why? I'm wondering whether you see my console, or shall I use a bigger character? Can you give me feedback about the way you see my console, whether you need a bigger character? Yes means that you need a bigger character. Is that true? So I'll increase the character size. I think 18 must be okay. Is that better? Or even bigger? Bigger than this? So it is okay. Now it is okay. All right. If it is okay, this is good. I can make it bigger, but then I do not manage to fit so many characters in the window. So we need to have it big enough so that you can see it, but not too big. If this is okay, I will keep it like this. So you're saying me that it is okay, right? So I wrote why assignment. So the assignment is this character. I'll use the console to pass you the characters. It is less than plus dash. It's 2 characters, and please do not put spaces in between, otherwise it is not interpreted as an assignment character. So what we are doing now is assigning to a name to the number 5. And we are creating a variable named y to store the character, the number 5. That is not number. To me, it is a constant, right? So the command is like this. I'll pass you the whole command across the chat box. And you see it in my console. Then I send this command to the console by pressing Command Return. With Windows, you will press Control Return or Control R, or you can use your right key on the mouse. I don't have it on my Mac computer, but you should have it in your Windows computer. There is another possibility that you use the, I'm looking for it, not sure that it is here, must be here in code. Yeah, here we go. Run selected line. Right, so you can do it by, you can send commands to the console by using Ctrl+R, which is my favorite way, or you can use the menu, or you can use right mouse click. I'm using command return because I have a Mac. So you see that the command is gone to the console and it's been executed, but nothing is shown. And that, of course, because we only said to R, please store the constant 5 into the letter, the variable y. Right? And you see that we have in the global environment pane, it is compared this assignment. So it is telling us that the constant 5 has been assigned to the value y. Right? So now we have this sort of, it is a sort of a box inside our computer's memory where we store the one character. So we can do things like multiplying y by 5. And you see that if I do like this and send the command to the console, the result appears. So we can use R pretty as much as a calculator. So we can add 2 and we get the results. And of course, we can assign the result to another variable. For example, we could create the variable x to which we assign the result of multiplying y by 5. So you see that if we do like this, nothing appears in the console because we didn't ask R to show us the result. We just asked R to store the result into the variable x, and the variable x is now in our global environment. So this is a very basic principle of how we use R. We create objects, store them in variables, and make operations with those objects. Right? So far? So let's do one final thing, and then I'd like to have feedback from you. When we use the script to write a long list of commands, it is very handy to save these commands. And we do so by using the menu here, File, Save As, and then we use the corresponding windows to save this script. I'm saving it in a folder of my choice, and you can do the same, of course. I'm writing to what I want to tell you is that I will put this file in UniStudio so that we can share the code. But I hope you are able to follow me and write your own script. I'm putting it here. And I will save it as first lesson. Or perhaps I should use the date of today. So it's 2020 09 30. So that it is easier to remember when we made some particular lesson. Right. Please note what we are saving is the list of comments, i.e. we are saving the script. A script must be executed, meaning must be sent to the console before we have our objects stored in the workspace or environment, as you would like to call it. So we have a workspace where our objects are, we have a script pane where we write comments, and we have a console pane where all operate, right? So a workspace or environment, a script, and a console. I'd like to have feedback from you. Is everything clear so far? Any questions, any request of clarification? Whatever. No feedback. It is clear. Thank you. Thank you for your feedback. Hope that you're just Control Enter is okay. Yes, Control Return, Control Enter. I was just saying return, but it's the same key, Enter or Return. You can use Control Enter or Control R. So Claudia, thank you for your request. We can use. It depends on the operating system. What operating systems do you have, Claudia? Windows. So with Windows, you can use Control R, Control plus Return or Enter. It is the same. They are the same key. Then you can use, I believe you can use right click. And if you use right click, a voice like send to R should appear, or you use the menu code and run selected line, send to R or code plus, then you follow with send selected lines. This is menu, right? So you see that I'm writing on the console and R is complaining. And you see it's telling me that I made mistakes here. You see this white cross here? He's telling me I'm making mistakes. Of course, I'm not writing R code here. I'm commenting. And in order to comment, we use the fences. And you see that if I put fences in front of the line, the error disappears because these are comments. R will not execute these comments. You see, I'm sending them to the console and nothing is executed, and R is not complaining because it knows these are just comments. So it is really important that you write comments in your code, because that is what helps you remember the comments when you are at home. Any other questions? If not, let's look at this slide here. We can have different data types, numeric constants, and I said that before. We have integers, there is a difference between numeric constant and integers. Integers are numbers like 1, 2, 3, 4, 5 with no decimal parts. What number? Numeric data types. The numeric type is a number with decimals. And we can have roughly 16 decimals in R. And afterwards, they are not considered. They are no longer considered. So the smallest number is 1000 raised to minus 16, something like this. Then we have character, the character type. That is for strings of characters, and we need to use quotation marks. For example, if I want to write my name and assign it to a variable, I need to write Andrea with quotation marks. That is the name of my daughter, Martina, and if I want to write to use the name of my daughter, I need to use quotation marks. Then we have factors. And I will tell you about factors in a moment. I want to tell you before that there is another data type, which is the logic data type, Boolean character, that is true or false, right? So let's go and experience with factors and characters. I will write a comment here, factors and characters. Now I'm creating an object, a different object, which is the vector. It is no longer a constant. I'll show you. Let's name this vector, well, hello. That is the name. Then we assign. And what do we assign? We assign a vector. A vector is a collection of characters, a collection of data. In this case, it is a collection of characters. I can create, for example, this vector, Andrea. Then I use the column to part the different elements of a vector. So I repeat Andrea, then I write Martina, that is my daughter, and again my daughter. So look, I'm making stupid things here. Look at me, I wrote Martina with capital letter, and that is a mistake because that would be different from Martina with small letter. So I will correct, but pay attention to this because it's really very common to make such type of mistakes. So this is our assignment here, and I will pass it through the chat so that you can check here, or you can copy it if you like to do so. I'm creating a new object, which is a vector containing characters. It contains 4 elements, which are the same 2 by 2. I leave you a few seconds to complete this comment. You are okay if you can see the hello up here, the object hello, and it is telling us that this is a vector, a character vector. Look at the difference here. Before we had a constant, now we have a character vector. What do the square brackets mean? The square brackets mean the index. The index, each element in a vector is indexed by position. So we have the first element here, the second, the third, and the fourth. The column here means that you have from 1 to 4 positions. So this is a vector with 4 elements indexed with the numbers from 1 to 4, right? So if I write, for example, hello, and I put the square brackets here, and I write 1, and I send this comment to the console, it answers with Andrea. Obviously, this is the element in the first position of the hello vector, right? So let's try to call the element in the fourth position, and that is Martina. And let's call the element in the fifth position. That's not available. You see, NA, not available. Of course, this vector has 4 elements, not 5, right? So this is a character vector, and it is different from a factor. A factor stands for experimental factors, and it recognizes that there are levels. So if I write something like factor hello and send it to the console, look, I'm sending to the console, I'm asking for executing a command, and I'm telling R, please transform the vector hello into a factor, and I'm using a function. And you see that I'm using a function because I have the word factor with open parenthesis, open bracket, and then the argument inside and closing brackets. So functions are made like this. They have a name, they have brackets, and inside brackets we need to put the arguments for the function. We will talk about this in a few seconds, but let's send this command here. So you see that the output has changed because we see factor hello, and it says Andrea, Andrea, Martina, Martina, levels Andrea, Martina. So you see that this is a factor with 2 levels. And I can assign it to the name hello dot f to mean that this is a factor. And you see that now in the environment I have 2 objects, hello, which is a character vector, and hello.f, which is a factor with 2 levels, right? So these are different objects, and the factor and the character vector, these are different objects, and they are used in a different way, but we need to know that R is clever enough to transform the object into each other if necessary. So we can, that has to do with functions. Some functions require factors and some functions require vectors of characters. And sometimes R is able to guess what the object we want to pass and change the object accordingly, but that's not always true. So we need to be precise with objects. So, is that clear? So I'm doing this in this slide. What I'm doing was the factor has some predefined levels, and it is useful to store the experimental variables. In this case, here I used a factor with 3 levels, A, B, B, C, C. And when we make it a factor, then it appears the list of elements with the number of levels. In this case, we have 3 levels. And this is a factor with 3 levels. All the other objects, vectors are really very important. I want to write a new vector with numbers, just to make some further practice. For example, we can create a vector, we can call it num, no, not that's reserved, let's call it, I don't know, I have not much fantasy with names, call num, to say that this is a collection of numbers. You see how I'm separating the different parts of the name by using a capital letter in the middle. This is the so-called camel case. Assignment, then create a vector by using the function c. This is a function because I have the name of the function, which is c, and the brackets. Inside the brackets, I need to put the arguments, which are the elements. So 4, 5, 6, 7, 8, 9. There are quicker ways to create such series of numbers, but let's do this like I did it now. Remember, vectors are collections of values, either characters or numbers, and we need to separate the arguments with a comma. Right? I said this. So it is interesting to know that R uses the so-called vectorization process. What does this mean? If I take a vector, such as call num, and multiply it by 5, all elements are multiplied by 5. So R is vectorizing the operations. This is interesting. I can do lots of quick operations by exploiting this vectorization. Fine. No. Let's go. That's good. Good question. Thank you, Florinda. I put a space between the elements, but this is irrelevant. I mean, you can either put the space or not. It's not important. Spaces can be put everywhere. Of course, they cannot be put here. If I put a space here between call and num, that is a mistake, because then the variable is no longer the variable we intend. But here I can put spaces wherever I want. It's no problem. I put the spaces because I think it's clearer to read, but you are not forced to put the spaces. I do hope okay, thank you. Thank you for your feedback. Thank you for your feedback. Now, I want to show you that we can have, I already talked about vectors. I show you now another object, another type of object, which is the so-called, so we have been talking about constants, we have been talking about vectors, now we talk about matrices. Matrices. Well, I'm looking at the watch and it's 11:27. So I think I'd rather not introduce the matrices now. I think it is the best if we simply stop here and we go ahead next time. Yeah, I think it is better because, well, if we introduce the matrices, it takes maybe more than a couple of minutes, and it's a pity if we start and we can't finish. So far, I think it's more than enough. We open R, we start writing comments. I recommend that you save your script so that you can open it again next time, and we go ahead next Monday. So I'd like to thank you very much for your attention and for your feedback. See you next Monday. And thank you again. If you have questions, you can ask questions now. I'm still here for a few minutes. Otherwise, you simply go. Yes, you can. Yes, Florinda, you can save the script simply as we did before. But before we used the save as. Now we can use simply save because we already given a name to this script. It's like you do with Word or whatever else. Well, you may have noted that the default extension is .r, and that's important because these are simply text files. But then if you use the extension .r, you recognize that these are R files. So this is a matrix, small repetition, maybe it could help. We created a vector. I created a vector here at line 6. Then I loaded the vector inside a matrix. And I named the matrix as Claudia, just because Claudia is here. Then I explored. I asked her at line 9, I asked her to see the matrix. And here we go. Right? Any questions about the matrix? At the argument by row, you mean? So I'm changing now the argument by row from true to false. What is that? I pass the command to the console, then I explore the matrix and look at the difference between the two matrices. In the first case, you have 1, 2, 3 along the rows, because I said by row equal false. So that should be true. The first one was true here. By row equal true. Then the matrix was filled in by row. 1, 2, 3, 4, 5, 6. And if I write by row equal false, then the matrix is loaded by column. So you see 1, 2, 3, 4, 5, 6 in the different columns. So here we go now. We pass to the next object. So we've been talking about matrices. Then we need to talk about data frames. This is perhaps the most important type of data. A data frame is a table, like a matrix, but the advantage is that columns can contain data of different types. So, for example, now I'm preparing a data frame going up so that you see a little bit better what I'm doing. First of all, try to do the same thing I did here. I create a vector now named plot. So, better. I call this ID, right? And I use 1, 2, 3, 4, 5, and 6. It takes a little bit of time to write these 6 numbers here, so I can replace this by using this command here. 1, 2, 6. Right? So, oops, sorry. So I'm passing you this command here just to show you that we can create vectors in a slightly quicker way by using this kind of syntax here. So that means from 1 to 6. But, I mean, it's correct also if you list all the numbers. Of course, if you have 10,000 numbers to list, that would take time. So you simply use this command from 1 to the number you want to go up to. And that's okay. So this is my first vector. Then my second vector. Let's say the vector about names. So let me load something like, so this is a character vector now. We have 6 individuals. They are numbered by using the numbers from 1 to 6. And then we need to write the names of the individuals. For example, the first observation is taken on Andrea. The second one is also taken on the individual Andrea. The third is taken on Claudia. And the fourth one is also taken on Claudia. I'm going to a new line here because my space is over. The fifth observation is taken on Martina. And then the sixth observation is taken on Martina. So we have 6 observations, and the ID of this observation is written into the vector ID. Then in the second vector, we have written the names of the subjects to which the observation belongs. Then let me assume that we have recorded some characteristic of Andrea, Claudia, and Martina. And this is the traits. And we have taken 2 measurements per individual. So maybe Andrea, the first measurement was 17 and the second 19. Then for Claudia, the first observation was 14 and the second was 12. And then for Martina, we had the first observation, which was 21, and the second observation, which was 23. So sort of writing a table of data. And this is a database. But now it is written as 3 separate vectors. Now I want to put all the 3 vectors together in one data frame. So the name of the data frame might be DF. That's just an abbreviation for data frame. And then I use the function data frame. Look at the name of the function, data.frame. So everything else would be incorrect. And be careful, we have the brackets, opening and closing brackets, and then inside we write the arguments. So now I need to list all the vectors which I want to include in the data frame, and remember that these vectors will be the columns of the new data frame. So I simply list ID, careful to how to write your names, and trait. Right? Pass the comment on. You see, I made a mistake here. Why? Because I didn't create the vectors before. So I need to create the vector ID by passing the comment to the console. Then I need to create the vector names. Then I need to create the vector trait. And then finally, I need to create the data frame. And then I can explore the data frame. And I get the table. But this is not a matrix, because you see, I have numbers, objects of different types, because I have characters and numbers all together. So I think it might be useful if I send the comments to you over the console. You don't need to see me. So now what I could do is to remove ed, names, and trait. I no longer need these vectors because I have the data frame now. So it's very convenient to keep the workspace clean. So I remove these objects here. I still have the data frame. That was not removed. Look at your workspace here. We got the DF data frame. We got Andrea and Martina. That were the vectors I created before. But we can clean again. So we remove also Andrea and Martina. So that now we are left only with one object. I can always explore the workspace by using the command ls list. That says, oh, we also have Claudia, the matrix we had before. Right, so look at me. This is for cleaning and exploring the workspace in the console. RM stands for remove, and you can remove objects if you no longer need them. You can explore object by calling their name, and you can explore the workspace by using the command ls. These are all functions you need to learn because we will use them during the course a lot. So, any questions? Claudia? Answer to Larissa, I erase something I have created. As I did, you use the function rm and list the objects you want to erase inside the brackets. Right? Now I have to go and check the problem with Claudia.
you have created the landscape, no? Which is where questo oggetto
So the problem with Claudia was that she had created the object here at line 17. Then she said, but I can't see the object in the console. Of course, this first command just creates the object. If you want to see the object, you need to call it by name, right? Nicola doesn't find names. Are you sure you have created the names? And be careful to how you wrote names. So be careful to capital letters, small letters, because if you use, for example, here at line 13, names, everything small, and then here you use name with capital letter, of course, R will not find your vector. So be careful to how you wrote the names and make sure you have created the vector before loading it into the data frame. You see, we need to be, in order to work with this program, we need to be very, tidy. We need to be very tidy, because if we make any sort of mistake, R will not understand us. It's not a living person. Or it is simply doing what we ask it to do. Keep going, Nicola. Okay. What was your mistake? Just tell us so that we can learn from your mistake. Making mistake is terrible because it takes time, but then we have to learn from our mistake. What was your mistake, Nicola? Doesn't tell us. Never mind. Okay, I used names first, and okay. So what I suspected. You must see, when we make mistakes, there are stupid mistakes. Well, now look at me, Larissa. You need to make sure. Let me see. Not sure I understand your question, but if you want to remove something from the workspace, this thing you want to remove must be in the workspace. So you need to create the thing before and then remove it. For example, now I'm cleaning everything by using this command here. We used it last time already. I'm cleaning everything. My workspace is clean. I create the first vector. I create the second vector. I create the third vector. And then I create the data frame. This is logic. Now I can remove everything I want. So I can remove the vectors, and the data frame is still there. Now I can remove the data frame. So nothing is left. Now I can't remove now, for example, the vector ID because I removed it already before. So I don't know whether this solves your problem, Larissa. So try to be consistent. Remove everything. Load the vector, load the second vector, load the third, create the data frame. Then you can remove whatever object you no longer need. Is that okay? Yeah? What is interesting is that you can save these objects. Now, we can save the script, and we know that already. For example, now I'm saving this script with the date of today, save as here we go. I'll get one directory, which is good. I had the script of last time. Finally, I will merge the two and put them over the UniStudio platform. Today is 2020, and then it is October, and then it is the 5th of October. So I'm saving the script. But this might not be enough. For example, we might like to save a data frame. For example, to export it to Excel. What do? We simply use the write. Oh, sorry, made a mistake. Write.csv. If you are set in Italian, you should use the function csv2. Then I tell the name of the object I want to save, that is df, and the name of the external file. For example, the name might be df.csv. Be careful. If I do like this, R will save this data frame, but where R is working on a so-called working directory. And it is generally a directory which we do not care about, because it is somewhere in the system where the installation of R is located. So what we need to do is to change the working directory. If we want to establish a connection with our hard disk, then we need to set the working directory. That's a place where R is gonna look for objects, file, and where it is going to save files, objects, and whatever. This is easy because we can do this by using the menu. So we have here session, set working directory, and then I can set the working directory to search file location. That means that I'm going to save the data frame in the same location as where I saved the script. And it is always a good idea to put the script and the data together in the same folder. So now, if I do something like this, I can save my data frame as an Excel table in the same folder where the script is. And if you go to my folder here, you can see it. You know, I think you can see here, I have df.csv file, which is newly created, and it is our table. So we can create objects inside R and send them to Excel, and we can also do the opposite thing. That is, we can create data frames in Excel and import them into R. And we will see how we can do that later on. Any other question? Okay. Now, I'm removing all this part here because I no longer need it.
Oops, sorry. So here we have an example with a data frame. This other slide just tell us how we can view objects, and I said that already. Simply use their name. We call objects simply by name. This is very important. That is indexing. So let me look at the data frame now. df. Can you see it? Now I can index. That means I can get one particular element of an object. For example, with the data frame, I use square brackets. And I use integers. For example, I want to get the element which is in the third row and second column. Third row and second column. First the row and next the column. So the object would be the character, third row, second column, Claudia. Here R is writing the row names. These are internal names. They are not used. What we put in the data frame was the ID column. So this is the first column. This is the second column. We are asking for the third element in the second column, which is Claudia. And you see that if I write df and index third row and second Claudia. So we can do lots of indexing here. For example, 2 and 3. In this case, we are asking for the object in the second row, third column, which is 19, right? And I can also index rows and columns. For example, if I write df square brackets, and you see I put 2, comma, and nothing, that means all columns of second row. And I get the entire second row. And of course, I can also index the column, doing like this. You see, now I have the row index, which is empty. And so I'm asking all rows for the third column. And here we go. We have the third column. So this would be indexing. Indexing. Now there is another way which is very important, and you need to learn this because we will use it very often from now on. We can also use extractors. What is the extractor? That is the dollar sign. And you see that if I write df dollar, RStudio is helping me and listing the columns. I am extracting a column from a data frame. So ID, or perhaps it is better if I want to get the names. So I'm getting the second column, the column labeled names. This is important. This is very important because the vectors inside a data frame are not accessible if I do not specify the name of the data frame and use an extractor, right? And this is very important. For example, I'll show you. I want to calculate, we will talk about this tomorrow, but just an anticipation. I want to calculate the mean, the average value, for the third column. So what do? I use the function mean and pass in the column. Oops. So what I'm passing is a stupidity. It is total dumb. I mean, I'm asking her to ask the mean for the names. And of course, he says, no, I can't. So what I can do is to calculate the mean for the trait. And that's it. I mean, we have 17.767. So this is very important. We can index by using indices, or we can extract columns from data frames, and this is very important. Both are important. So you can find everything here. Indexing columns and rows. We can access vector columns by using the extractor, that is the dollar operator, or the dollar sign, as you want to call it. Now we can use expressions, but we already use them. I mean, I can take objects and make some operations. For example, I can take the object df and tray and multiply by 5. I mean, sorry, there is a mistake here. Every element in the vector is multiplied. R is vectorizing, and I think we spoke about that last time. Okay? So, it is vectorizing, so we can make operations, and operations can be used to create new variables, like here, if we need them. We have talked about functions and arguments. So a function says brackets. Inside the brackets, I have arguments. And if I have multiple arguments, either we supply them in the exact order with which R expects them. So if we supply them in the exact order, we don't need to write the argument name, or much better, as a suggestion, become used to using argument names. So if you use argument names, you have no problems. You cannot make mistakes. We can use the RL to see a list of the expected arguments for each function. So what we did so far, right? I have some examples here. So it might be worth just to go through this. This is the logarithm function, and it has two arguments. The first one is the number which we want to calculate the logarithm of, and the second is the base. So if I use this ordering, I can avoid writing the argument names, which is easier. If I use argument names, then I can swap the arguments. If I don't use the name, I can't swap the arguments. Otherwise, R is misinterpreting and giving wrong results. That's why I said, if possible, write the argument names. Otherwise, you can't make mistakes. And if you don't realize you have made a mistake, then it's a problem. So let's see some common functions. Some functions. What I'm thinking, if you agree, I will go ahead until 1:15, roughly. Then we stop, because I have another lesson at 2:30, and I'd like to go back and feed my children, and then come back for the next lesson at 2:30. So if you agree, we will not pause today, and we'll go home. You're already home, but we go home 15 minutes earlier. So, some common functions. This is the first one. Sometimes I can create sequences. I've seen that I can create a sequence like this. Let's call it A. 1, 2, 8, so on. This is a sequence for, you see, A is 1, 2, 8. But this is not the only way to create sequences. We can create more complex sequences. For example, by using the sec function, then I need to tell R from equal from equal 1 to equal 10 by equal, for example, 2. So I'm creating a series from 1 to 10 with a step equal to 2. So this is more flexible. And I can do whatever I want. This is one of the cases where, as we have only 3 arguments, they are really very logical. We can avoid using them because it's easy to remember them. So this is the short form. It means create a sequence from 1 to 10 with a step 2. So we might have step 3. You go. Right. So this is the first function I wanted to talk about, creating sequences. All right. Then the next function, repeating values. This is also very useful. We have written here, we have used this. So you see that it's really not very quick because I have to write the names, and we have to use the, I'm missing now, what do we call this kind of characters here? Gosh, sorry, getting old and forgetting words. But you see, we have to write this, then the name, then again this, then comma, and then whatever, it takes time. So we can repeat. For example, if I write rep, I can repeat, for example, rep 1 3 times. So I get 3 times 1. So I can rep a name, Andrea, 2 times, twice. And you see, it writes Andrea, Andrea. All right. I can do something more. I can take a vector names, a new vector name, write it simply like this, Andrea, Claudia, so I have the 3 names, and Martina. This is quicker. And then I can wrap the whole vector names twice or 3 times or whatever. For example, I can repeat twice. So what I get is really, it is not exactly what I want. Sorry, I didn't pass this. So I need to pass names before and then wrap. And you see that I'm getting something which is different from what I expected because R is repeating the whole vector twice. But I want to repeat the single elements of the vector twice. So I write each equal to. Look, it's very logic here. So working with R at first is really scary. But then, after a while, it becomes more comfortable. At least this is the impression that all the students before you had. At the beginning, they were scared. But then, they got used. You go. You see that this is exactly what we expect. It is repeating every name twice, not the whole vector. This is very tremendously useful. So you look at here, I'm summarizing the whole situation in the slide. These slides are already loaded on UniStudio. So another common function, cbind or rbind. I can take one. So this is to create matrices. We have created a matrix before, like this, Claudia, by using this syntax here, function matrix. This is not really always useful because I have to create a whole vector before and then I have to load it into a matrix. Sometimes it is more useful to create the rows of the matrix or the columns. For example, what I can have col1, which is the numbers 1 and 2. Then I have col2, and I put the numbers 3 and 4. Then I have col3 and put on the numbers 5 and 6. Then I can, these are columns, so I can cbind col1, col2, and col3, and then I create a matrix joining the different columns. Of course, I can also, these are 3 columns, but just assume there were 3 rows. I can bind the rows, rbind. In this case, if I bind the rows, well, what I get is this one. Of course, I'm binding rows. So that depends on what we need. And these are matrices. They are not data frames. They are matrices. So this is an alternative way to create matrices. And again, it is everything explained here. So, how can we know what an object is? We can have some ways to, let me create the second matrix. I call it Claudia 2. So we have, oops, what did I write? Okay, now let's go. So I have an object that is called Claudia. I don't know what the object is. I can get info by using str. str Claudia. What is Claudia? What kind of object is Claudia? Claudia is not found because I erased it, so I'm gonna create it again. Oh gosh, I need to go to the very beginning, take Andrea, take Martina, create the matrix. Then I'm working for 2 hours, and I do not use the matrix Claudia anymore, so I forgot what Claudia is. I saw that it is in my workspace, but I have forgotten what the object is this. So I used str Claudia, and it says that it's a numeric object with 2 indices. The index for rows goes from 1 to 2. The index for columns goes from 1 to 3, and it contains the numbers 1, 2, 3, 4, 5, and 6. I can do this with a data frame. str, df, you know, it says something different. It says it is a data frame. So I know what the object is. And this is very important. I can summarize objects, and this is a method, and it gives me information about objects, statistical information, and the information retrieved depends from the object. So, for example, with a data frame, we get such an information. We have the 3 columns, and for each column, we get the minimum, the first quartile, the median, the mean, the third quartile, and the maximum, because this is a numeric column with names. It says length 6, it is a character. And for trait, numeric, other information. So we can summarize objects. So summary, DF, and it might be different from summary Claudia, because Claudia is a matrix. I suspect it will give the same answer. Yes, it does. But in some cases, the information we get depends from the object, and it might be different. So STR is useful to know the type of object. In summary, it's useful to have statistical information about objects. These are 2 other important functions. I am more or less telling you all the functions you need to know. So this is useful because you must know from now on that these objects and things you perhaps would need to know. What do I do? I'm working with R for maybe 8-10 hours a day, and I have in my dozens of functions, syntaxes, and I always forget them. You are lucky because you are young and your brain is certainly more developed than mine, which is going down little by little. But I have here a small application which I use to remember things. So all the most important things about R, I note them here so that I can recall them when I need to work. And you can do this. Please remember that if you prepare a sort of a memory in a simple file, then you can keep it with you at the exam. Because it's no point that you learn everything by heart. You simply can't learn everything by heart. So you have to get organized. And I'm, in some ways, evaluating your organization, not your memory. I'm more interested in thinking that you are organized. Even if you forget things, I always forget things. So, well, we have talked about the extractors, the $sign, to get the different slots of objects. Well, for example, I want to show you, this is written here. I have the matrix Claudia in the workspace. Claudia. That's a matrix. Perhaps you know that one matrix, one function that I can calculate with matrix is, so one operation is obtaining the eigenvalues and eigenvectors of a matrix. If you do not know what eigenvalues and eigenvectors are, it doesn't matter actually. I just want to show you, if I use this command with Claudia, sorry Claudia, I'm mentioning you quite often today. I can create a new object, new eigen Claudia. Oops, that's not a square, sorry. What could we do to reduce this matrix to a square? For example, we could take only the first, so you remember, Claudia is this matrix here. So we have 3 columns and 2 rows. To get a square matrix, we need to remove the 3rd column. So we can use indexing. So I take all rows, but remove the 3rd column. So I'm writing -3. I do this like here. So you see, I'm getting a square matrix because I have removed the final column. So you see, I can index, but I can also remove by using indexing. So now I can use the function because I have a square matrix. Because I said, okay, please calculate eigenvalues and eigenvectors of the matrix Claudia, but before doing this, remove the 3rd column. Is that clear? So the object contains 2 slots, eigenvalues and eigenvectors, and I can access them by using the extractor. This is a list, right? So extractors are useful whenever objects have more than 1 slot. Right. And I think we are done. All right, so we should talk about some simple graphs, but we'll introduce graphs tomorrow. Tomorrow we will start talking about statistics, and we will use these functions so far. So if you take maybe half an hour this afternoon and just go through what we have done today, it might be useful.